All right. I would have missed this one on the exam. No, I wouldn't have. I would have stopped and got 11/3 and realized I did it wrong. All right, 2y squared. Here's what you got to do. This is a good practice. Separate the variables. So you got dy is equal to 2y squared dx. And then you look at it and you realize these don't agree. So what do you need to do? Move the y squared over. So you're going to have 1 over y squared on the other side, dy, is equal to 2 dx. Now some people are like, can I bring the 2 over? It doesn't matter where you put the 2. 2 can go on either side because it's not a variable. It can be 2 over here or 1/2 over here. It's up to you. So then I'm going to have y to the negative 2 dy equals 2 dx. What do we do now? This is a straight just differential equation problem. All right, add 1 back to the exponent. What are you going to get? Yeah, you're going to get y to the negative 1. Divide by that, you're going to get negative 1. You're going to have a plus c, but where are we going to chuck the plus c at? Where are we going to put plus c? We'll just put it all on the other side. So we're going to have 2x plus c over here. So you're right. I'm going to come over here. We're going to have negative 1 over y is equal to 2x plus c. Now, you can really solve for c at any point, but as soon as you plug in, you can't change c anymore. I can keep changing c and calling it c and calling it whatever I want, but as soon as you plug in, you're done doing that. What's the point they gave you to find c? Right there. So we've got y of 1 is equal to negative 1. So it would be negative 1 over negative 1 equals 2 times 1 plus c. It's one of the reasons I don't like doing it this way because it takes so long. It would have been so much better if we could have done start plus displacement. So much faster. So we're going to have positive 1 equals 2 plus c. What's c? How about negative 1? Okay?
Oh, jeez.
Okay, so now we've got negative 1 over y equals 2x minus 1. Have I even answered the question still? No, what's the question answer? When x is 2, what's y? Now you can plug 2 in for x and solve for y. So what's 2 times 2? 4 minus 1. So you got negative 1 over y is equal to 3. Cross multiply, you'll get 3y is equal to negative 1. What's y equal? Negative 1/3. Yeah, it's a long problem if you can't do start plus displacement. Do you see why I tried to avoid that? Because otherwise you got to go through all the steps of solving a differential equation. You got to go back, find the plus c, and then you can plug in. If you can do start plus displacement, you can bypass all that. The problem is it wasn't in terms of x. So you had no, they forced your hand. They forced you to solve a differential equation. Okay? All right, 34. This is a related rate problem. 35 is a good problem. All right, take a look at this. On the top of a ladder, 25-foot ladder is sliding down a vertical wall. So here we go, got a vertical wall. All right, we got the ladder, and let's pretend Kyle's on top of the ladder. And the ladder's sliding away from the wall. So it's a certain distance away from the wall. Does everybody agree? Okay, this would be Eli, because he's trying to pull a wall with the ladder. Okay, 25-foot ladder. How long is the ladder? How long is it? 25. I'm going to ask you something in a second here. Okay? And we're going to practice some of these next week when we just start reviewing. And I've got a little strategy you can do so you can get these right. Because you're going to see 2 or 3 of them. And they're always triangles, circles, or cones, or cylinders. They're always the same thing. All right? If you get like this, it's going to be very similar to the one last week we did that was a right triangle. It's going to be Pythagorean theorem again. Anytime you get a triangle, it's going to be Pythagorean theorem. So you got top of a 25-foot ladder sliding down a vertical wall at a constant rate of 3 feet per minute. Now, sliding down a vertical wall at a constant rate of 3 feet per second. So we're sliding down the wall at a constant rate of 3 feet per second. We need a variable here. What do you want to let this variable be? The vertical variable. Let's call this y. Let's call this one x. So what is the rate for y?
3 feet per minute.
All right, ready? It's dy. Remember what we do this with respect to. We don't do it with respect to x. You may remember what? dy dt. And what did it say the rate is? Now the question is this distance increasing or decreasing? Really important here. Decreasing. So is that derivative negative or positive? So it's negative 3 feet per second. Minute, sorry. Thank you. Negative 3 feet per minute. Okay? when the ladder is 7 feet from the ground, all right, when the ladder gets to 7 feet from the ground, so in other words, when y equals 7, okay, what is the rate of change of the distance between the bottom of the ladder and the wall? So this is the one I'm after. I'm after, okay, here's what the rate is. The ladder is sliding down the wall at negative 3 feet per minute. When it gets to 7 feet above ground, how fast is this one changing? I want to know dx dt. All right, here's the key. Once you've identified everything that you know, all the quantities you know, the ones that you're looking for, here's the key. I need a variable that relates this one, and this one. Now, let me talk about this one a second, because here's what's really cool about this one. Does the ladder distance ever change? Does it change? What will the ladder always be? It'll always be 25. Since this one's always 25, you can plug it in before you take a derivative because it's never changing. So what's the equation that relates x, y, and 25? Pythagorean theorem. X squared plus y squared equals 25 squared. Now some of you are going to be like, why didn't you plug the 7 in? Because this one's what? What is the y doing? The y is changing. Is the ladder changing? So you can only plug a constant in when it's not changing. That's the only time you're allowed to plug in, because we know we're going to have to get to a derivative because we're talking about rates. All right, let's take the derivative implicitly here because it's with respect to what? It's dy, d, and dx, d. So we got to do it implicitly for x and y. All right, how do you take the derivative of x squared? 2x times dx dt plus derivative of y squared. Next Monday and Tuesday, I'm just going to practice a bunch of these with you in class. Equals, what's the derivative of 25 squared? What's the derivative of constant? 0. Now, plug in what you know. What do you know? Do we know dy dt? Yeah. Do we know x? Let me ask you, do we know x? Can you find x? If you know this one's 7 now you know y is 7, and you know this is always 25, what is x going to be? How can you find x? Pythagorean theorem, you just go x squared plus 7 squared is equal to 25 squared. Let's see, that's going to be x squared plus 49 equals 625. Don't worry, you'd have a calculator for this one, I guarantee you. Somebody have 625 minus 49. Who's got a calculator handy? Huh? Is it 586?
No, 576.
Is it 576? There should be a square root of that. What is it?
576.
What's the square root of 576? 24? Good, perfect. So there you go, 24. X is 24. So now we know x is 24. What was the question asking you to find? What's the rate of change of the distance between the bottom of the ladder and the wall? So they want to know that. Want to know dx dt. So that's going to be our variable. What was y? 7. What was dy dt? Negative 3. The hardest part is getting the equation set up. Once you get the equation set up, it's just taking a derivative and plugging in stuff. All right, so this is going to be 14 times negative 3. What's that? Don't ask me. I messed up math today. Is it negative 42? That's 48. Dx dt equals 0. Add the 42. We're going to get dx dt. It's going to be 42 divided by 48. So what is that? Simplify 2. Huh? 7/8. Why is it positive? What's happening to this distance as the ladder slides away from the wall? It's getting bigger. It's increasing. The derivative should be positive. Positive derivatives indicates increasing. Negative derivative indicates decreasing. The answer. Now I know right now a lot of you are just like barely trying to understand that. Like I said, I'm trying to teach you this kind of word problems on the fly. We'll practice that next week when we just do a lot of review. Yeah, it is kind of like your response. Like I said, the further you get in the exam, the harder the problems get. Okay, let's finish up a couple more. This one's a really good one. Very easy if you know what you're doing. All right, horizontal asymptote, y equals 2. This is good review. Awesome review. Haven't done it for a while. How do you find a horizontal asymptote? This will be interesting. In behavior. How do you do in behavior? Limit as x approaches what? Infinity and negative infinity. So if I have this, and I want to find its horizontal asymptotes, I got to think of the limit as x approaches positive and negative infinity of ax plus b over x plus c. But here's the deal. Since there's no square roots and no piecewise, is it going to matter if we go to positive or negative infinity? Is there anything piecewise about this? So what should the end behaviors be?
Positive.
Is it going to matter if we go to positive and negative infinity? Are the end behaviors going to be different? No, they should be what? Should be the same. So let's just check it. Limit as x approaches infinity. All right, since it's a fraction, what rule do we get to use? It's a shortcut. It's going to be very good, Ben. Way to speak up. It's the ratio of the coefficients. Largest power on top is this. Largest power on this. You can disregard this junk. So it's just a ratio of the coefficients. So the horizontal asymptote has to be a. Do you realize that it wouldn't have mattered if you would have went to negative infinity? Because there's nothing piecewise there to make you change the sign and make it negative a. Okay? So the horizontal asymptote's a. A. Okay, so there's the HA. Y equals A. Well, wait a second. Didn't they tell us the horizontal asymptote? The problem, they told it's Y equals 2. So what does that tell us A is, though? A is 2. Now, the next one I think you guys would get. Vertical asymptote I'm not too worried about. When can you find the vertical asymptote? When the denominator equals what? 0. So x plus c has to equal 0. Well, what did they tell us the VA is? So that means x is what? So c equals 3. We now know A, we now know C. Now we can answer the question, what's A plus C? 2 plus 3 is 5. Yeah. Most people just need to review what a horizontal and vertical asymptote is. Guys, whenever you are doing a horizontal asymptote, it's the limit as x approaches positive and negative infinity. Now, usually you don't have to worry about approaching both because they're usually the same at both ends. Unless you get like something like this, like an absolute values where positive infinity would be positive x and negative infinity would be negative x. Otherwise, it's going to be the same at both ends. If it's not, then you're going to get one's going to be positive, one's going to be negative at one end, and that's the deal. Okay, a few more questions because some of these we got to start skipping because they were BC stuff. If the definite integral from 0 to 2 of e to the x squared dx is approximated by using two inscribed rectangles of equal width, and then approximated by using the trapezoidal rule, the difference between the two approximations is, wow, I can't believe they gave you that on the, it seemed like a free response. Oh, no, it's not. Think about it. You don't even need to know what e to the x squared looks like. Let's just draw a graph. Watch this. Let's just say it's this. Okay? And I want to do two rectangles from 0 to 2. It's really easy to break this up. What's the two rectangles going to be? 0 to 1 and 1 to what? 2. All right. Two inscribed rectangles. That means they need to be on the inside. They usually don't use the word inscribed anymore. They usually just say left to right endpoint. But inscribed would mean you would have to think about it. Now, e to the x squared, if you don't know what it looks like, maybe you do need to kind of know what it looks like. This is the bell curve. Does anybody remember me telling you that?
Yeah.
Okay. So if I want it to be on the inside, would it take a right endpoint or a left endpoint to be on the inside? It would take a right endpoint. So watch. Right endpoint, that's an inscribed rectangle. One that's inside the area. So it'd be a right endpoint. So here we go. Two rectangles. What's the width of those rectangles? 1. Ready? 1 times the height. How are you going to get the height? So it's going to be 1 times e to the 1 squared. Plus, next rectangle, what's the width? 1 times e to the 2 squared. All right, take your calculator out real quick, somebody. This is going to be e plus, see, that's e first plus
E to the fourth.
Yeah, e to the 4th. Calculator, somebody. E plus e to the 4th, real quick. What do you get?
57.32.
3.2 what?
3.164.
3.6. Okay, there we go. That's that one. All right? And then if it's approximated using trapezoidal rule. All right, now let's do trapezoids. Same thing, watch. That was inscribed rectangles, right in point. Trapezoids, what do? You got two trapezoids, 1, 2, 1, 2. What do? Trapezoid, okay, apparently we haven't done enough trapezoid rule. We're going to do some trapezoid rule next week. All you do for trapezoids is you measure out both, and you connect the two to get a trapezoid. There's your two bases. There's your height. Then measure up here, measure up here. There it is. What's the height of the trapezoid? What's the height of the trapezoid here? All right, then you have to find base 1, base 2 for that one. Then you have to find base 1, base 2 for that one. All right, here we go. Let's add up this trapezoid first. So that one's going to be 1/2 times 1 times sum of the bases. This will be plug in what? 0. So it's going to be e to the 0 squared plus e to the 1 squared. There's the first trapezoid. Does that make sense?
What is that? N equals 2.
That's how many they want you to do.
Oh, okay.
2 rectangles, 2 trapezoids. Okay? Plus 1/2 times 1 again. Really, you could add the 1/2 times 1 where?
All front.
All the way out front. All right, this next trapezoid is going to be e to the 1 squared plus e to the 2 squared. All right, need a calculator again, John. I can help you a little bit. I can pull the 1/2 all the way out front. Ready? Let's pull the 1/2 all the way out front. This is just going to be what? That'll just be 1 plus e in parentheses plus, we pulled the 1/2 1 out front, and that'll be e plus e to the 4th. So if you'll do this for me, you'll go 1/2 times the whole quantity, 1 plus 2e. Can I speed that up? Is that really 2e? E plus e is 2e.
I already got it.
What do you got?
It's 30.51.
I don't
No,
want to know
that's
the
the
answer.
difference.
I want to know the answer. But
30.517.
this is 30.517?
Yeah, so 26.8.
30.517? The answer is not B. The answer is what's the difference between these two? What do you do?
D.
Subtract the 2. The answer has to be D.
Yeah.
Make sure you read it. That would be a mistake. People would easily glaze over that and be like, oh, I forgot to subtract them. Okay, next couple questions.
Wait.
Yeah. Yeah. Definitely going to have to do some Riemann sums and trapezoidal sums.
Got it.
Usually it's all in the free response now. If they ask you a multiple choice question with Riemann sum and trapezoidal rule, it's just, it says approximate using trapezoidal rule, or approximate using a left endpoint, or approximate using a right endpoint. I haven't seen the inscribed in a long time. Okay. If f is a differentiable function, what does that mean? It's continuous. Differentiability implies what, everybody? Continuity. Then f prime of a is given by which of the following? All right, they want you to know two formulas here. Alternate form of a derivative and definition of a derivative. Okay? F prime of a. Is this the definition of a derivative with a plugged in? That is. Remember, the definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. We put that on the calculus essentials. And then if you want to find f prime of a, all you do is plug a in for x. There it is. One is true. Definitely true. What about 2? I forgot to put this on the calculus essentials. 2 is also true. That's an alternate form of a derivative. I forgot to put that on the calculus essentials. Make me remind you to put that on there today. You have to know that. It's the limit as x approaches a constant of f of x minus f of a over x minus a. That is the alternate form of a derivative. Now, does this work? No. No. Our definition of derivative, h has to approach what? That doesn't work. So it's 1 and 2 only. That's just knowing two definitions. That's all it is, knowing two definitions. There's only two definitions for a derivative. There's the definition of derivative, and then there's the alternate form. That one's pretty easy if you know your two definitions. Okay? A couple more questions, and then we'll answer homework questions if you got them. If the second derivative is this, which of the following could be? Could be. Now, here's the thing. If I have the second derivative and I want to know what f of x is, once I do the antiderivative of the second derivative to get to the first, you've got a what? Come on. You've got a what? Don't make me work for it. Okay, let me do it. Thank you. All right, so let's do it. 2x minus cosine x dx. What's the antiderivative of 2x?
X squared.
X squared. What's antiderivative of negative cosine x? Negative sine x plus c. So you got this plus c hanging out there. Well, what's the antiderivative of it? Let's get back to the original.
X to the third over.
All right, we're going to have x to the third over 3. Those 3 are gone.
Plus cosine x.
Plus cosine x. Looks like this one's gone. This would be a plus cx, but do we know what that c is?
Nah.
Could it make it negative 1? Could c be a negative 1? And then there's another plus c. We'll call that c sub 2. Here's the deal. It said could be. So the answer has to be A. Because I don't know. I'm not going to be able to find the c's. I know it can't be these. Because I have to get x to the third over 3. I have to get a plus cosine x, and the only possibility is A. That one's not too bad. All right, here's another related rate problem. Okay, almost done here. Just, there's 3 in this last part that are BC questions because people were asking me yesterday. I think it was me and Michael were looking at it. All right, the radius of a circle is increasing at a non-zero rate. So you got a circle. This is actually one of the easiest related rate problems to do. You got the radius of a circle is increasing. So imagine you threw a rock in the pond because you're trying to impress your girlfriend by skipping rocks, but you can't skip them, so all you do is make ripples and make puddles. So you throw a rock into the pond and you get a circle. You know, concentric circles, you throw the rock in the pond. What happens to circles as you throw that rock in the pond? They're getting bigger. What's happening to the radius? What's happening to the area? What's happening to the circumference? Okay? That's right. So the radius of the circle is increasing. So R is increasing at a non-zero rate. So we know that's positive, dRdt. dRdt is increasing at a non-zero rate. And at a certain instant, the rate of increase in the area of the circle, let's call that dAdt. You'll get used to this. Next week I'll make you do a bunch of these. So we're just going to review and practice all next week. That's all we're going to do. Okay? The rate of increase of the area of a circle, dAdt, is numerically equal to, okay, listen, ready? The rate of increase in the area of a circle is numerically equal to the rate of increase in its circumference. Let's call that dCdt. At this instant, the radius of the circle is, I don't know.
One, just pick each one.
This instant, the radius of the circle is,
Yeah. Okay, just point at each one. D. There you go.
all right, let's start with the area formula. Let's start with A equals pi r squared. Let's see what happens. Oh, I got it. Here we go. This is cool. All right, let's start with the area formula for a circle. How many know the area formula for a circle? All right, ready? Let's find the derivative of the area formula for a circle. All right, you ready? Here we go. Area equals pi r squared. This actually is going to fall right out. You're going to see it. In fact, you guys will see it. What's derivative of A? dAdt. We don't know.
Oh.
Okay? So it's dAdt. Okay, you good with that?
Yeah.
All right, now watch this. Let's take the derivative of pi r squared. This is cool. What's the derivative of pi r squared?
0.
How would you get 0?
Pi is
pi r.
constant.
Yeah, but it's constant multiple. You got a variable.
It's 2 pi r.
So it's 2 pi r. Oh, interesting. Times, hold on, times the derivative of r, which is, oh, I got to go over this more next week. I don't have a clue. All right, so you get dAdt is equal to 2 pi r dRdt. You good with that? Now watch. It's set in the directions. That's cool. That's circumference, by the way. It's set in the directions. dAdt was equal to what? dCdt. So, yeah. This is circumference. What do I got to do with that?
Integral.
I thought this was going to fall right out. It's not falling right out, and I'm not going to sit here and spend time on it. I want to say it's 1.
It is.
Is that the answer, really?
Yeah.
And I want to say it has something to do with these two being equal. but I'm not gonna sit here and think about it much longer. So I thought that would be way cooler. This next one, the graph of that y equals fx. Sorry, I guess I'll have to look at it later.
Morris, just quick analysis on that. You
Please
said circumference, rate of circumference equals just the increase, what is it, the rate of
Area.
So 2 pi r equals 2 pi, because you just divide out 2 pi's and you get r equals 1.
But it's the rate of circumference.
Yeah, but that is the rate of value.
Oh yeah, we gotta go back and find 2 pi r. So dc dt is what? What's dc dt?
It's 2 pi.
2 pi times dr dt, right? Oh, I just didn't do enough of the problem. Pi r squared. So what was dA dt? 2 pi r times dr dt. Oh, we were missing the second half. My fault. Thank you. So we got dA dt is 2 pi r dr dt. Then we got to do the derivative of circumference, which is dc dt is equal to 2 pi. These two things are what? Equal. Set them equal, and then you can solve for your. So if I set this equal to each other, you're going to get this right here equal to this right here. So we have 2 pi r times dr dt is equal to 2 pi. Is that what you were thinking, Michael?
Yeah, it's exactly the same thing.
All right, what happens to dr dt's? Cancels. What happens to 2 pi's? Cancel. What does r equal? My fault. It's silly. Twix up the kids. All right, 40. Almost done here. 40, the graph of y equals f of x is shown above. Which of the following could be a graph of y equals f times the absolute value of x? What was the answer here? C. So if you do this, right here, if you take the absolute value of -4, you get +4, and then that value's here, so this value gets shifted there. If you take the absolute value of -1, you get 1, which is still 0. So basically the graph's going to do this.
You just say that everything left from the whites is going to look like that. Everything.
It's going to mirror the right. Yep. Everything over here has to mirror this, because when you take the absolute value of anything over here, it has to end up being the same thing on the right, so it just mirrors it. Okay. They don't even ask these questions on the exam anymore like that. All right. This one right here, how many got this one? This is FTC part what? Part 1. All you do is plug what in? X. So the answer will be cosine 2 pi x d.
It was C. I think it said it was C. I just marked mine down wrong.
No, it's D.
Oh, cool.
Okay. Did we do 42?
Yeah,
this
we,
is-
we talked about 42.
We talked about it, but that's on the BC now, so don't worry about that.
What is it?
43, if you missed it, don't feel bad. On the BC, that's integration by parts. Anybody gonna take Calc 2 next year? After we're done with the exam, I'm gonna spend one day, because if you take Calc 2 in college, they will expect you to learn this even though you've had AB. It's the only thing we don't cover that they cover right away in Calc 2. So if you take Calc 2 in college, I'm gonna spend one day just showing it to you. I'm not gonna give you any homework on it. I'm gonna take Michael aside and anybody else that wants to, and just one day I'm gonna show you how to do integration by parts. It's pretty simple. It's like another U substitution, but instead of having just a U and a DU, it has a DV and a V. And then there's a formula memorized. And at least you'll be exposed to it. They will review it, but they'll expect that you've learned it before. So at least if you've seen it, you won't be caught off guard. Okay? So if you know you're going to take Calc 2 in college, be an engineer or something like that. What's the minimum value for this? This one right here is BC, so our last problem, and then I'll answer homework questions. This will be our last problem. 44. Can you do this one? How do you do the minimum value for something?
You do the critical value.
Critical value. So how do you find the derivative? What rule you got to use here? Product rule. So derivative first is what? Let's do it first. 1 times the second minus the derivative of the second times the first. This works out really well. So we're going to have ln x minus what? 1. Set the derivative equal to what? 0. So you get ln x minus 1 equals 0. So we're going to have ln x equals 1. What do you do to solve this? Go full circle. So what does x equal? X is equal to e. Does everybody see how x equals e? It's e here, e to the first equals x. Okay? So this must be the minimum value. Or it has no minimum. Alright, we had to do a sign it. The answer's C. What the heck did I do?
What is the value?
Oh, minimum value, value. Minimum value. Keyword is value here. They're not wanting to know where it's at, they're wanting to know what it is. So once I determine, and if you want to check it real quick, it's negative infinity to e and e to infinity to make sure it's a min, because it could be this one. I'm not saying it is. Now, we already know the answer C. But that's what I was about to conclude because I didn't read the direction. So let's plug 0 in. 0 is going to make the derivative what? Oh, wait, you can't do natural log of 0, so we can't do that. So let's do 1 will make that. Yeah, 1 will work. 1 will make this what? 0 minus 1 is what? Negative positive. So is it a min? Therefore, we know there's an answer, so it can't be that one now. Now we just got to plug e into the original function. If I plug e into the original function, I'm going to have e times natural log of e.
What's the answer?
Natural log of e cancels. I still get e. Okay, please tell me what I did wrong now, because I'm obviously not doing good this morning.
Are you guys certain C is the right answer?
You certain C is it?
That's what you told us.
What did you get?
I guess I had E. I had no value, but I also had one.
Derivative first. Get your homework out. I'll answer a question on your homework. Derivative first times the second minus derivative second.
Is it minus 1 though?
Oh my god. Product rules plus.
Yeah.
God, I am off this morning. Y'all have kept me way too early. Now watch. Here's what you do. Watch. Here's why the answer is E. You get natural log of x equals negative 1. It's e to the here's why the answer C. You get e to the negative 1 is, so you get x equals 1 over e, right? Then you plug that in. Now you plug that in, so you're going to get 1 over e times natural log of 1 over e. So natural log of 1 over e, watch this, is natural log of e to the negative 1. What happens to ln and e? Cancel each other out. What are you left with? Negative 1. What's negative 1 times 1 over e? Sorry, way off today. Not on my A game. Lost my mojo. I got to find it.